Hello friends, today's project is automatic bathroom light. Using this simple circuit, you can control your bathroom light. Whenever you open the bathroom door, light will automatically turn on. You will close the door and the light will be on. Again when you open the door to come out from the bathroom, light will turn off. Let us take a look at the component list to develop this project. You need to have a LM7805 5V voltage regulator IC to get a fixed 5V supply to a circuit. A 741 operation amplifier IC used as a comparator. 4017 decade counter IC in which we used only two outputs to control a circuit. 5V relay that will govern opening and closing of bathroom light. 2N2219 NPN transistor to drive the relay. Small normally closed type glass reed switch that will be installed in the movable part of the bathroom door. A 5 LED that represents bathroom door in our prototype. BC557 PNP transistor with the reed switch. A magnet to be installed at the bathroom door fixed side. Apart from these components, a transformer, a bridge rectifier, some resistor, some capacitor, and jumper wires are required. Let us take a look at the circuit now. When the bathroom door is open initially, the reed switch contacts are open and the PNP transistor does not conduct. In this situation, the voltage at pin 3, that is non-inverting terminal of 741 operation amplifier IC, is lower than the voltage at pin 2, that is inverting terminal of 741 IC. We have given supply voltage as reference voltage at pin 2 of 741 IC. The decade counter IC 4017 is getting clock from 741 operation amplifier IC. Hence in this case, the decade counter will not get any clock and it will not start its working. When the bathroom door is opened by a user, the magnet and the reed switch moves away from each other. The reed switch contacts close and the PNP transistor starts conducting. Now, the voltage at the non-inverting terminal of 741 IC is greater than the inverting terminal and its output goes from low to high. This provides a clock to a decade counter. In response to the decade counter, the relay driving NPN transistor will start conducting and the bathroom light is turned on. Now, once you enter the bathroom and closes the door, the reed switch contacts are open and the PNP transistor does not conduct. Again, non-inverting terminal input will fall below the inverting terminal input and decade counter will not get any clock. But in this case, the shift is from 1 to 0 and that is the falling edge of the clock and our decade counter is working only on the rising edge of the clock. Hence, the relay remains energized and the bathroom light keeps glowing. When you open the bathroom door again to take an exit from the bathroom, the PNP transistor will start conducting. Again, the non-inverting terminal input will be high as compared to the inverting terminal input and the decade counter will get a clock. This time again the rise is from 0 to 1, which is the rising edge of the clock, and the relay drive NPN transistor stops conducting. As the result, the bathroom light will turn off. To install this in your bathroom, assemble this circuit on PCB and enclose it in a suitable box. Connect the bathroom bulb switch in place of this LED. The heart of this circuit is the combination of magnet and normally closed type of reed switch, which are installed opposite to each other in the bathroom's door frame and the door respectively. So, when the door is closed, the reed switch contacts open, and when the door is open, its contacts close. Let us see a demonstration of this prototype circuit. Connect the power supply to the circuit. You have opened the door, enter the bathroom and close the door from inside. You can see the LED is glowing, representing bathroom light. Now you open the door to take an exit from the bathroom and the light is turned off automatically. This is all about this project. We hope you liked it. Do implement this project at home and let us know your experience. Thank you.